Hello, we from Session 3 and today we're gonna present about Google File System. This is our member. First is Mr. Sutthiphon, next is Mr. Pawaris, and finally is me, Mr. Supawit. First, let's get started with what is Google File System. Google File System or GFS is a scalable distributed file system or DFS created by Google company and developed to accommodate Google expanding data processing requirements. Google File System provides fault tolerance, reliability, availability, scalability, and performance to large network and connected with several nodes. Google File System is made up of several storage systems built from low-cost commodity hardware components. Google File System optimized to accommodate Google different data in use and storage in need. For example, is a search engine will generate a huge amount of data that have been stored. Finally, Google File System is capitalized on the strength of off-the-shelf server, minimizing hardware weakness. Next, Mr. Sutthiphon will talk about design of GFS.
Hello. Thank you, Mr. Swan. I will talk about the design of Google File System. I will divide my title into four parts, with our master, chunk server, client, and chunk size. So for master, the master is socially responsible for the file system metadata. This allows for a simple centralized master that does not become a bottleneck. Next, chunk server. Chunk server do not cache file data because files are too large to be cached. Primary chunk server are responsible for data mutation and replacing to secondary replicants. For the clients, clients initially interact with the master of metadata. After that, the client communicates directly with the chunk server. Lastly, chunk size. Files are divided into fixed size 64 megabyte chunks. Each chunk is identified by a globally unique 64-bit chunks handle. So next, Mr. Pawaris will talk more about Google File System.
Okay, when you with a relative small number of the server, the file system achieve reading performance comparable to a single disk for 80 to 100 megabytes per second, but had a reduced write performance to 30 megabytes per second, and is the relative slow to the 5 megabytes per second in the appending data to the existing file. The read rate increased significantly with the number of the chunk server achieving 583 megabytes per second for 342 nodes. Thank you.